will see the reactions involving gases. Okay, so the reactions involving gases, see, suppose, like in chemistry or in science, some of the things are, very amazing, very, sometimes, we cannot digest, we cannot believe it, that, okay, this is the reaction pattern it is happening. So, for example, okay, let this be on beaker. Okay, so there are some gas particles in it. And this be the beaker, this being the next one. So this is again another beacon, so let it be. This be the next one. Okay, this be the next one. Suppose, in this or this beaker, it is going to have a, let it be, the volume is 22.4 liter. Okay, so 22.4 liter of a particular, so this jar, it is 22.4 liter, this one 22.4, or this 3 it is 22.4. So this gas, let it be nitrogen gas. So you have filled here. Here actually, here it is, let it be oxygen gas. Here it is actually chlorine. So let it be, so this is going to be chlorine. And this is going to be, let it be helium. This is going to be hydrogen. This is going to be carbon dioxide. Carbon dioxide gas. Okay. So you said that all this it is maintaining at the standard temperature and pressure. So let it be same temperature 25 degrees Celsius. The pressure it could be 1 atmospheric pressure. So 1 atmospheric pressure, and so that is the thing. So if you measure the number of particles here, if you measure the mass of the oxygen, mass of the chlorine, okay, number of particles here, in all these, the number of particles it is going to be 6.023 into 10 raised to 23 number of particles are supposed to be present. Okay, so these many particles are the one it is going to be present. And if you measure the mass, it is exactly it is going to be 1 mole. So here also, in nitrogen also, oxygen also, chlorine also, helium also, hydrogen also, CO2 also, it is supposed to be this is going to be 1 mole of the gas it is supposed to be present. Okay, see, maybe if you measure in the first case, this is going to be 28 gram. If you measure oxygen, in this case, it is going to be 32 gram of oxygen is supposed to be there. So here actually chlorine, it is 71 gram. So it is actually 4 gram. Here actually 2 gram. Here CO2, it is 44 gram. So the mass is, the number of moles it is in all bottles at this particular volume, when the temperature, when the volume is actually 22.4 liter. Okay, so this is supposed to be, 22.4 liter volume is supposed to be there. Okay, and so that is the reality. These gases, it is it is going to occupy the same volume. Okay, and if you are going to measure in another way, you take let it be, this is one beaker. So this is going to be, see, 100 ml of beaker. So, or like not beaker, this is supposed to be a chamber. Okay. So this is again, like 100 ml of. So here actually gas particles are there. Here actually gas particles are there. So here also 100 ml is there. So this is actually carbon dioxide. Let this be the so let this be helium. In this both case we are taking same volume, temperature and pressure, it is in both case it is same. So in this case also number of if you count the number of particles, in both case it is going to be same. So same volume of anything, same volume of gases, it will occupy same volume of gases, it is going to occupy same number of particles. Okay, so 100 ml of carbon dioxide and 100 ml of Cl2, it is going to occupy the same volume of same number of particles. Okay, so this is the reality, and so now like that is one of the realization, like the same number of particles it is going to occupy, same volume of the particles it is going to occupy same number of particles. Okay, so this law we call it as Avogadro's. Actually, in fact, this law also discovered by Avogadro. So we call it as Avogadro's gaseous law. Okay, thank you. Now we can have some questions. See, for example, see, you are taking a how much volume? One question is, so you are having 0.025 moles of a particular gas. Okay, how much volume it is going to occupy? So that is the question. So the volume, how much is going to be the volume it is going to occupy? See, 1 mole it is going to occupy. I told you it is 22.4 liter. But for easiness and for most of the calculational purpose, we can write it is actually 24 liter. Okay, 24 liter. So 1 mole is going to occupy 24 liter. So 0.025 mole, it is going to occupy 0.025 into 24. So this is going to be, so if you calculate it, like it is going to be 6 liter. So this is how we can calculate. See, now let it be another question. Suppose you are having 22 gram of carbon dioxide, it is there. 22 gram of carbon dioxide is going to be there. Okay, how much volume? How much volume this is going to occupy? See, now for this question, like a number of moles you can calculate. 22 divided by 44. So this is going to be 0.5 mole. Okay, 0.5 moles it is going to occupy. So now 0.5 moles if it is going to occupy, like then this is so how much volume this is going to occupy? So 1 mole it is going to occupy, as you said, like a 24 liter. So 24 liter. So 0.5 mole let it be 0.5 mole. So this is going to occupy 0.5 into 22.4 liter. Okay, so 0.5 into 22.4 liter. So again, this is going to be, sorry, not 22.4, actually 24. So again, this is going to be like, so 12 liter it is going to occupy. Okay, probably in your textbook, instead of liter, they are saying decimeter cube. Okay, liter and decimeter cube, it is nothing but the same. Now, if you are calculating the gaseous volume from equations, okay, we will see. For example, 2H2 plus O2, so this gives 2H2O. Okay, so this is a gas, this is a gas. So mostly this also, the water also is going to become a gas. So like what we can understand is, see here, See, according to this equation, suppose you are given, see, here if you are taking in terms of moles, okay, so 2 moles, that means 2 into 24 liter react with the 24 liter of oxygen to form 2 into 24 liter of water molecules. So here actually let it be 48. For example, here in this equation it is actually 48 liter of hydrogen react to form 24 liter of react with the 24 liter of oxygen to form 48 liter of water molecules. So this is how the reaction it is going to come. Okay, and if you are going to take another equation, see, let it be, you take one equation, S plus O2 SO2. So these are actually gases. Okay, so these are actually gases. So here it is 1 mole of sulfur, it react with the 1 mole of oxygen, it will form 1 mole of SO2. So this is like a 32 gram of sulfur, it is supposed to react with the we have to talk more in terms of volume. So it is going to be 24 liter. Okay, let it be here. Where will I write? Okay, I will write it here again. So according to this equation, all are gases, right? Sorry, sulfur is a solid. This is a gas. This is also a gas. So so here it is. Suppose if 1 mole is reacting, so 32 gram of SO2 it react with 32 gram or 22.24 liter of oxygen react to form 24 liter of sulfur dioxide. Okay, so this is how the reaction it is going to come. 24 liter of sulfur dioxide it is going to form, and so this is how we can just immediately predict from number of moles and immediately we can predict. For example, 2 H2, you take this reaction H2 plus Cl2, it is actually 2 HCl. See here, H2 is a gas, this is a gas, this is also a gas, HCl is also a gas, right? So here one thing suppose if 1 gram of H2 is reacting with the excess amount of chlorine. Let it be, we don't know the amount of chlorine. Okay, so 1 gram of hydrogen is reacting with the excess amount of chlorine. It is supposed to form HCl, right? So what you can understand. See, 1 gram is actually nothing but how many moles? So it is actually mass divided by molecular weight. So this is actually 1 divided by 1 divided by 2. So this is a 0.5 mole. So here actually 0.5 mole react with the 0.5 mole because it is in the 1:1 ratio. H2 and Cl2, it is in the 1:1 ratio, right? 0.5 mole react with the 0.5 mole of Cl2 to form. So actually this is in 1:2 ratio, right? So it is going to be 1 mole of HCl. So yeah, all are gases. So then we will see how many moles. So this is going to be 24 liter divided by 2. This is also 24 liter divided by 2. So this is actually going to be 24 liter. So this is a 12 liter of hydrogen react with the 12 liter of oxygen. Okay, to form 24 liter. Okay, so please remember these ratios, how we can manipulate and how we can do the calculations. Okay, so we will see some of the calculations here down. Okay.